So the lawnmower is now brought to a stop. Calculate the magnitude of the constant force that must be applied through the handle in order to accelerate the lawnmower from rest to 2 meters per second in a time of 3 seconds. So now they want us to find the force that must be applied. Firstly, we have to determine our acceleration. So we know that our acceleration is the change in velocity divided by the change in time. So in this case, our final velocity, that's gonna be 2. Our initial velocity, 0. Our time, it's gonna go to 3 seconds. So it's gonna go from 0 to 3 seconds. So 2, 3. Basically an acceleration of 0.67 meters per second squared. So now that we know our acceleration, we also know that our force so our frictional force, I think it was somewhere around let me just go back and let me go back. I think I might have made a mistake by rubbing out the frictional force, but let me just rewrite it. 90 plus 320. Our frictional force, that's gonna be 68.95. So they say assume that the frictional force is gonna remain the same. So now we have our acceleration, we have our frictional force. We know that our F net will still be equal to our frictional force our force applied minus our frictional force. But in this particular case, our F net, according to Newton's second law, is gonna be our mass multiplied by the acceleration, F net. So in this case, it's not gonna be 0 newtons. We have our acceleration, which is 0.67. Multiply that by 15. We're gonna get 10.05 newtons. So that's our net force. So here we're gonna substitute our values. It's gonna be 10.0. Oh, sorry. First, let me make our force applied the subject of the formula to make it easier. So our applied force is going to be equal to our net force, F net, and the sum of our net force and our friction. So this is way simpler at this point. You're just going to substitute in. You're going to get your 10.05. And you're going to add it to your 68.95. Then 10.05 plus 68.95. You're gonna get 79 newtons. So that's gonna be the amount of force that you have to apply on the lawnmower for it to accelerate from 0 to 2 meters per second in 3 seconds. So do you understand so far? So I didn't lose you.
Yes, sir.
Okay. So, and the next question is here: a planet Y has a radius of 6 times 10 to the exponent 5 meters. A 10 kg mass weighs 20 newtons on the surface of the planet. They want us to calculate the mass of the planet. In this case, you're gonna have to use Newton's law of universal gravitation, where you're gonna have your force being G M divided by R. I think, yeah, it's R squared. So they want you to find the mass of the planet. I'm sorry, let me just look at this formula again. I think it's M1, M2, but let me just make sure. This is for the gravitation. This is for G, which is the force of gravity. What's the value of G, of a big letter G? 6.67 times 6.67 10 to the exponent 11. Sorry, so it's gonna be M1 and M2. I'm sorry about that. So now we know our force, that's 20 newtons. We have our mass. Let's say the mass, let's say this 10 kilogram, let's make it M1. And we have our radius, and G is a constant. So now we have to find M2. We can just start off by making M2 the subject of our formula. So this is gonna go to that. Then this is gonna be here. Then you're gonna have M2 is equal to your force, the radius squared, divided by G M1. Now, after you have this, it's just simple. You just substitute from there on. So you're gonna have your 20 newtons, your 6 times 10 to the exponent 5, which is gonna be squared. Then down here, you're gonna have your G, which is 6.67 times 10 to the exponent -11. And you're gonna multiply it by your 10 kilograms. Let me just make sure about the value of G, because I'm not so sure. Let me just go down. Yeah. So from substituting, we can calculate the mass of the planet, which is going to be M2. So that's going to be 26 times 10 exponent 5 squared exponent -11 multiplied by 10. Your mass is 1.08 10 to the exponent 22 kilograms. So that's going to be the mass of the planet Y. So unfortunately, we only have 7 minutes left. But I hope through this session, like you got a bit of help, and you understand how to do this a bit better now. But is there any questions on any of the questions that I did?
So I got a different answer.
For when you substituted?
For the whole thing, sir.
For 2.2?
Yes, sir.
Okay.
Oh, never mind. Sorry, I substituted wrong.
Oh, okay. But so I think since you're writing Friday, tomorrow you'll tell me when you'll be free, so we can have another session, and I'll give you some tips on how you should write your exams. Is that fine?
Yes, sir. So tomorrow I'm free again, like after 5, but Thursday I'm free all day because I don't write, so I'm at home that whole day.
Oh, okay. Let me just check my load shedding schedule, because I think, unfortunately tomorrow I have to let me stop recording.